and a lot of other things. I don't know, do you know of anyone who's looked at that? I can imagine it'd be such a pain in the butt because they have so many, you know, response difficulties. But maybe with eye tracking or something like that, I think that's completely doable. It's just, you know, getting the response out of them is the hard part. Do people do that?
I haven't seen it much, but
Yeah.
I mean, I'll check that out. The visual world paradigm especially.
Yeah.
I know Sean Redmond's done some stuff in children with ADHD, language impairment, and typical children looking at eye duration and search patterns.
Mhm.
He's got some stuff.
Are the language impaired kids faster at visual search?
I can't remember because I focused in on the ADHD piece of it, and they are just scattered all over the place. They would be looking at the umbrella, and they would hear beaker, and they'd still be looking at the umbrella going, how does the umbrella fit into here? And they'd have like, he showed some. And then eventually they would look at beaker. It's what I remember was the thing that stuck in my mind. And then, so I can't remember what the LI kids were doing in that.
That's really interesting because there's like some research that working memory capacity and intentional control are related, like to ADHD and all that, I imagine. But there's research that shows that people with increased working memory capacity aren't better searchers. There's no program that doesn't vary with working memory, so that's super interesting.
And these were, of course, he mostly works with kids, so you could also get some of the results they could be getting are just, you know, developmental attention spans in addition.
Yeah.
But the typical kids, I think they said they performed like adults, just a little bit slower, and then the ADHD kids were kind of all over the place.
Very interesting.
Yeah, I think it'd be really cool if we had a few patients that could sit still to do eye tracking and not have to get to go to the bathroom every 2 minutes for you. But to, you know, to do something like this, that, you know, their IQ is quite high. They have no major decision-making impairments, or, you know, other things that might have a problem. Their vision's intact, yet they, you know, they cannot name things very well at all, and they make a ton of phonological errors or just can't get it out. You know, it's just extremely non-fluent. But they have, you know, intact visual spatial memory and things like that.
But are they able to read and they're able to, like in the verbal?
Yeah, so I'm thinking like kind of like a classic Broca's person, right? So reading is basically fine. Certainly for single words, it's no problem. And then coming up with those words orally is impossible.
Yeah.
And they have a hard time writing them too. It's just like a, you know.
Wow.
But it would be really cool if they were faster.
That would be
fantastic.
That's a very cool idea.
I mean, it's, you know, it is messy because it's never just this nice little package, but
it'd be tough to get the
yeah, but I think
The eye tracking is clever.
But I think the eye tracking is how you do it, because it's the more and more stuff that comes out from my lab, but many other labs too. You know, with bigger and better stuff is that it's the decision that these folks are impairing at. So if you can get some other measure, like I say, well, give me thousands of dollars and go down to the scanner. But for something like this, I mean, I think the eye tracking would be really cool.
Yeah. Do they look at visual search and decision making? Because there's a lot of search studies that look at those decision processes.
Yeah, but I don't think. I mean, I just don't look at lesion stuff, you know, in the visual domain only, you know, like in object land. So I'm not sure, but that's really interesting. I'm gonna kind of look into that.
Yeah.
Talk to Steve.
Yeah,
Yeah.
definitely.
I think that'd be cool.
Is there any way to see these things unfolding over time? Presumably there is some millisecond transmission times involved.
Yeah, I mean, people use EEG for this a lot, right?
For visual search?
Yeah.
They've done, I think Stephen Luck has done some
Yeah. You can also do, I'm thinking of fMRI, but you can do some pattern classification in primary areas to, I mean, again, probably eye tracking is just the better way to go for this, but you can tell, you know, the brain can distinguish between looking at phonological distractors versus looking at a semantic distractor or a visual shape distractor or things like that.
Mm-hmm.
But in a case like this, I don't know if it would tell you much different than, you know, than eye tracking. Unless you had people, it was more of an attention issue, so you just had people fixating, you know, at something and then, you know, having to modulate their attention somehow would be of interest. But otherwise, it's probably just as great to have, you know, fixation durations.
All right, how would you learn something new from this kind of paradigm? we know, I think, that you activate all kinds of things concurrently.
Mhm.
How are you going to learn something new about that process?
I think in the visual search literature, it's more of an issue in which people have focused too much on just visual properties of images, for instance. The visual world paradigm stuff, that's sort of like in between the language and the visual search literature, where there's a lot of researchers, when I discovered this, I didn't really recognize, any of their work. I never heard about it before. I thought it was really cool. And so I think it's more of an idea that we're discovering that these processes happen very, very quickly and in sort of more traditional visual search type environments. So for example, in a lot of the visual world paradigm, there's only 4 very simple images on the display. And they record eye movements, whether they fell into that quadrant or that quadrant, for example. But with our paradigm, we have more of a cluttered display, more of a difficult visual search task. It's cognitively demanding. People are asked specifically to find something as quickly as possible. And if people were relying just on visual information, then these effects wouldn't emerge. But that's sort of been the standard assumption in visual search literature, is that this is visual information. Now it's starting to change a little bit. People are interested in more things, but I think it shows that it happens in a very demanding task, in real time, very quickly, to a degree that it affects you in very subtle ways. It just sort of isolates a pretty cool, pretty non-intuitive effect in the context of visual search, basically.
So if the Department of Defense wants to give you a lot of money to enhance elite soldiers' visual search, what do they do? Right?
Yeah.
Honestly, I would go more into the prevalence literature. So there's a big push for studying prevalence research. Basically, there's an effect called the low prevalence effect, where airport screeners, for example, they search through bags all the time. They search through passenger bags thousands of times a day, probably. They see a lot of water bottles, but they don't see a lot of weapons. Consequently, they become expert water bottle detectors and very bad weapon detectors. They actually show that when a weapon occurs, they're more likely to miss it because they encounter so many water bottles, a high prevalence item. And it's sort of like a criterion shift in signal detection terms. But basically, we found in our lab that people often look directly at the target and say that it's not there. If it's the rare target, their eyes will land directly on it and they'll say, nope, didn't see anything. So if it was Department of Defense and training soldiers in the field, these effects undoubtedly arise in combat type situations. So what we would do is, if an enemy soldier dresses up as a pink bunny or something, that's a real low prevalence event. Not that would happen, but just an example, they might be more susceptible to rare changes in new enemy tactics that they've never encountered before, and that sort of thing. So I would encourage them to train. There's a thing called prevalence retraining. So if you bring these airport screeners out of the scanning environment and retrain them with 2 objects that are equally prevalent, that sort of resets their the Bayesian machinery in their mind to a degree, and it makes them more sensitive to the low prevalence targets. It's not actually sensitivity change, it's criterion shift. So that they actually become more able to detect these targets temporarily, but then the prevalence effect again builds up over time. So I would encourage that sort of prevalence retraining type scenario.
You can do that for the IED or whatever, the explosive devices.
Yeah.
Detecting them on the roadway.
Mm-hmm. Yeah.
Oh yeah, that would be really
Because they see a lot of rocks, right?
Yeah, they see a lot of rocks. So, that's a rock, oh, boom.
Boom, yeah.
Yeah.
It's over.
No rock, that's something else. Yeah.
I have one last question. For your articulatory suppression one that didn't change anything, what were they articulating?
2 random digits between 1 and 9. So 0, 1, 3, 1, 3, 1, 3, 1, 3, just
Okay.
continuously.
And who decided that?
I
You
think
told them.
Yeah, I think there was another experiment.
You just let them pick two numbers.
Oh, no, they were
Or-
randomly
oh,
generated. Yeah, and each trial.
The computer randomly generated it.
Yeah,
for-
yeah,
oh,
yeah,
okay,
yeah,
great.
randomly. Yeah, so yeah, these effects seem to survive articulatory suppression, which is pretty interesting. So we ran a follow-up experiment that I still have to analyze. It's like just a standard Baddeley articulatory suppression task from like Baddeley 68, I think,
Yeah.
where he has, I forget what people repeat, but it's not numbers, but we did basically his exact paradigm, but with the numbers from our experiment to show that they do work in a memory environment, but
Oh, cool, yeah.
so that the,
Sweet.
Yeah, that's a great idea.
so we're gonna actually, analyze that data, those data, and see if they work out, and then
Cool.
break that one up.
Yeah, that's a great way to
Yeah.
make sure that it's suppressing something, right?
It was suggested by Hunter Ball over at, he was a memory researcher in our department, and then
Yeah.
a student that just graduated, and then a lady, Kathleen Moore, visual search researcher at OPAM. She suggested that to me, which is a little vision conference, and she suggested, articulatory suppression may kill that effect, but surprisingly it didn't. It was interesting.
Cool.
Well, good, thank you.
Thanks so much.
Thank you very much. I really appreciate it.